Hello guys, so I would like us to look at practical problems involving binomial expansion. So if you're given a question like this, C is equal to PV cubed, and then you're being told to determine the percentage change in C if P is increased by 3% and V is decreased by 1.2%. Now, basically, the original value, as you can see, of C is whole. So the original value, as we've been given, C is equal to PV cubed. This is whole. This is like 1. And what happens to P? P is being increased by 3%. So the new value of P will be equal to 1 plus 0.03 of P because it is being increased. And then what is the new value of V? Since it's being decreased, V was initially whole, so it will be 1 minus 0.012 because 1.2% is the same as 1.2 divided by 100, which gives this. So this is the new value of V. So what is the new value of C? The new value of C will be C is given by PV cubed, and this is our new P value. So this is 1 plus 0.03 P multiplied with the new value of V is 1 minus 0.012 of V, and V is cubed, so we cube this. So our new C will be given by, so write the whole of this formula. As you can see, we have PV cubed here, so I can write PV cubed here. Then the remaining bits, which we will expand using binomial theorem, 1 minus 0.012 raised to power 3. So this is raised to power 1, nothing much to be expanded there. We expand this. So 1 minus 0.012 raised to power 3. I can also write this as 1 plus minus 0.012 raised to power 3. Now, here, when we come to carry out this expansion, we're only going to write the first 2 terms of this expansion. So that's how we go about it. I'll have 1 raised to power 3 plus 3, 1 raised to power 2 multiplied with minus 0.012. Okay, so this is what we get, and this gives me 1 minus 0.036. So bringing it back into the equation, our new C is equivalent to PV cubed. We have 1 plus 0.03 multiplied with 1 minus 0.036. Now carrying out this expansion, taking 1, multiplying this bracket, I have 1 minus 0.036. Taking 0.03, multiplying this, I have plus 0.03. Now this term right here that multiplies this one, I will neglect because it will be very small, so it is negligible. So I will not write that. So evaluating that, we have our new C as PV cubed, and then 1 minus 0.36 plus 0.03 will give us 0.994. Now, initially, C was whole, it was 1. And right now, our C is 0.994. So what has happened? C has obviously decreased. And by what percent? So initially, C was 1. And right now, it is 0.994. So what is the difference? 1 minus 0.994 gives us 0.006. And what is this in percentage? So 1, 2, that is the same as 0.6 over 100, which is obviously 0.6%, and it is a decrease, as you can see. So basically, that's how we go about solving such questions. So taking up another example, we are being told that f is equivalent to 1 over 2 pi, the square root of k over I. Determine the percentage change in f if k is measured 4% too large and I is measured 2% too small. So initially f was a whole. F was whole the way it is. But now what is going to be our new f? Our new f is going to be, so we are going to input in the changes. So 1 over 2 pi what's the new value of K? Now, K is measured 4% too large. So it basically increases by 4%. So that is 1 plus 0.04 K. That is the new value of K. All this divided by what of I? I is measured 2% too small. So I will be 1 minus 0.02 I. Then we go on and evaluate this using binomial theorem. Now I can take out this whole formula because it's present here, so that I write this value as 1 over 2 pi. Then I have square root of K over I, and then it will be visible what exactly I'm remaining with that I'm supposed to evaluate using binomial theorem. So that will be the square root of 1 plus 0.04, all this divided by 1 minus 0.02. Okay, so to enable me carry out this expansion nicely, I will bring this on top. So all these are raised to power a half. So I will have my value being 1 over 2 pi, the square root of K over I, and then 1 plus 0.04 raised to power a half, and then 1 minus 0.02 raised to the power minus a half, because I will be bringing it on top. Then carrying out the expansion for these two, remember, as I said, we are only going to write the first two terms. So for this particular expansion, 1 plus 0.04 raised to power a half, the first two terms will give us 1 raised to power a half plus a half, 1 raised to power a half minus 1, and then 0.04. Simplifying this, we get 1 plus 0.02. The other one, 1 minus 0.02 raised to the power minus a half. I will write it as 1 plus minus 0.02, and then I raise this to the power minus a half. So expanding this, I get 1 raised to the power minus a half plus minus a half, 1 raised to the power minus a half minus 1 multiplied with minus 0.02. And this will give me 1. Minus will give me positive, and then evaluating this will give me 0.01. Now coming back into my new F is equal to 1 over 2 pi, the square root of K over I, and then I have these two values here, this one and this one. So I'll just multiply them straight away, neglecting products of small terms. So taking this one, using it to multiply this bracket, I will have 1 plus 0.01 plus, taking 0.02, using it to multiply this bracket, I will have 0.02. And then since this value and this value, if you multiply them, they'll give us something so small. So we will neglect their product and only have these ones. So this will give me 1 over 2 pi, the square root of K over I. And what is this? If we evaluate this, we will get 1.03. Now, initially, as we can see, our value of F was whole, it was 1. But right now, we have our new F being 1.03. So basically, it's an increase. And it is an increase of, so 1.03, the new value minus 1, we get 0.03. So obviously, this has increased by, let's put it into percentage, it will be 3 over 100, which is the same as 3%. So 3% too large. It is an increase. So 3% too large. Now, the questions which come in this form, you're being told that prove that if X is so small, then this expression right here is equal to this. And after proving that, then by taking X is equal to 1 over 9, prove that root 5 is equal to this. Now we've already done, seen how to go about expanding this and showing that it is equal to this. You just come carry out the binomial expansion for this, neglecting X cubed and above, and you should get this. Now I want to show this second part. If you let X be 1 over 9, then prove that root of 5 is equal to 181 over 81. So in my values, instead of writing X, I will write 1 over 9. 1 minus 1 over 9. And remember, what I want to show is that root 5 is equal to 181 over 81. So on this other side, 1 plus, where there's x, I put 1 over 9, plus 1 over 2, where there's x, I put 1 over 9 squared. Now, simplifying this, 1 plus 1 over 9 is the same as 9 over 9 is the same as 10 over 9. Divide by this is 1 minus 1 over 9. 1 minus 1 over 9 is the same as 8 over 9. So if you're dividing by 8 over 9 is the same as multiplying by 9 over 8, the square root. And what does that give? So 2 goes here, and then we remain with that. So this will give the square root of 5 over 4 is equal to this other side, which is 1 plus 1 over 9 plus a half into 1 over 9 squared. Now, I can be able to simplify this as root 5 over root 4, but root 4 is 2, so I can just write this as 2 is equal to this other side, 1 plus 1 over 9 plus a half 1 over 9 squared. Now, remember, this question is telling us to, if we let x be 1 over 9, we prove that root 5 is equal to this. Now, we can be able to make root 5 the subject of our formula here. So what is root 5? Root 5 is the same as 1 plus 1 over 9 plus a half 1 over 9 squared, and then all this multiplied with 2. So root 5 will be equal to, so adding all this together, we should be able to, and simplifying, we will be able to get that this is equal to 181 over 81, hence the proof. So basically, that's how we go about proving such questions. We can take up a last example on this one. Let's say you're being told that after carrying out this expansion, so the fourth root of 1 plus x, and then plus the fourth root of 1 minus x is equal to a minus bx squared. So we're being told to get the value of a and b, neglecting higher powers of x. So basically x cubed and above are not given. So what is a and then what is b? After getting the value of a and b, the second part of the question says by letting x is equal to 1 over 16, we prove that the fourth root of 17 plus the fifth root of 15 is equal to 3.995. So I want us to start with this first part very fast, expand, and then get the values of a and b so that you can be able to show the next part. Now, what is 1 plus x raised to power 4? Remember, we are only going to expand all the way up to x squared because they've neglected x cubed and above. So this is 1, 4 plus 4, 1, 3, x plus 4, 3, 1, 2, and then x squared, all this divided by 2 factorial. Simplifying this, I have 1, no, the 2 factorial is on this last term, sorry. So all this divided by 2 factorial. So this is 1 plus 4x, and then this gives me, so 2 factorial is the same as 2. This gives me 6x squared. And then this other side, 1 minus x raised to the power 4. I will rewrite this as 1 plus minus x raised to power 4 so that I can be able to take this term as my second term. So this is 1 raised to power 4 plus 4, 1 raised to the power 3, then I have minus x plus 4, 3, 1 raised to power 2, then minus x squared. All this divided by 2 factorial. We're neglecting x cubed and above, so I'm expanding up to there. And simplifying this gives me 1 minus 4x, and then this other side, 2 factorial will go with this too. So I have, this will be positive x squared, so that will give me plus 6x x squared. Now these two have been added, as you can see, this added to this. So if I add these two, what do I get? So adding those two, 1 and 1 will give me 2. 4x minus 4x will give me 0. 6x squared plus 6x squared will give me plus 12x squared. So what is the value of a? From here, clearly a is 2 and b is equal to 12. Now, if this expansion gives me this side, when I let x is equal to 1 over 16, I need to show this other side. So we're going to let x be 1 over 16. So we've already discovered that if you have 4th root of 1 plus x plus the 4th root of 1 minus x, this will give 2 minus, sorry, it's 2 plus 12x squared. So the value of b is not positive, it's minus 12. Okay, so now, so if we let x be equal to, I hope there's no error in that question, or we've done it correctly. Let's just go over it again. This is 1, 4, x, 4, 3, x squared. And then this gives 1 plus 4x. This will give 6x squared. And then expanding this one, this is 1 raised to power 4 plus 4, 1. Then this is minus x. And then this is 4, 3, 1 minus x squared. So this will give minus 4x. And then this other side, we have 2, 6 x squared. So that's okay. So b is minus 12. Okay. So if that is the case, then b is minus 12, so a is 2 and b is minus 12. So this is what we're going to have. So replacing x with 1 over 16, what will you have on this other side? So I'll have 1 plus 1 over 16, 4th root, plus 1 minus 1 over 16 is equal to 2 plus 12, 1 over 16 squared. Okay, so evaluating that, what do we get? So what is 1 plus 1 over 16? So that will give 1 plus 1 over 16, that is the same as 17 over 16. And then we are supposed to get the 4th root and add it to, so 1 minus 1 over 16. So our 1 minus 1 over 16, that is the same as 15 over 16, 4th root. And this is equal to 2 plus 12 into 1 over 16. Okay, so that is equal to that. Okay, now, so let's evaluate. Remember, the question is asking for us to show that the 4th root of 17 plus 5th root of 15, 4th root of 15 is equal to 3.995. So from this, we can be able to simplify this and have the 4th root of 17 over the 4th root of 16 plus the 4th root of 15 over the 4th root of 16 is equal to this side over here. Now this will give me, I can put this under the same LCM. The 4th root of 16 is the same as 2. So 2, and then this gives me 17 raised to power a quarter plus 15 raised to power a quarter is equal to 2 plus 12, 1 over 16. So what is this? Because we were told to show that the 4th root of this, the 4th root of this is equal to 3.995. So you take this 2, multiply it on this other side. So you'll have 2 plus 12, 1 over 16, and then the whole of that multiplied with 2. So if you evaluate this, I'm sure you're going to get 3.9985. And that's how we solve that question. That's how we go about that question.